here's where the rubber meets the road. Here's where we answer that perpetual question of how many places do I round it to? Because after this lesson, you will know, okay? Or at least you'll be able to practice and get to know, all right? So, what place you're gonna round an answer to when you do your mathy thing depends on what mathy thing you do, all right? When you are adding or subtracting numbers, okay, what you're going to do is you're going to use the least number of decimal places, okay? You're going to round it to whatever place is the last known place, which remember is your last significant digit. So, for instance, the other rule is when multiplying or dividing, you're going to use the least total number of significant figures. Okay, examples. 5.44 plus 2.3. Boop, beep, beep, boop, boop. You plug that into your calculator and you get 7.74. Okay, but here's the thing. You only know this number to the 10th place. You don't know what number comes after the 10th place, okay, because your measurement doesn't take it out that far. So, is this number a 4? Maybe, but probably not. Because if this was 2.32, then that number's not a 4. So you don't know it. So the only thing you can tell me for certain is that you know it to the 10th place. Okay? So when you're doing this calculation, you're going to round it to whichever number is the last significant digit. So it becomes 7.7. Okay? When you're multiplying and dividing, all right, 7.923 times 75.3. Boop, beep, beep, boop, boop. And you get 596.6019. Okay? But here's the thing. You don't know all of those numbers. Okay? Therefore, this number right here has 1, 2, 3, 4 significant digits in it. This number right here has 1, 2, 3 significant digits in it. What you're going to do is you're going to round it to the least total number of significant digits, which is 3. So you're going to round it to 3 decimal places. Okay, or excuse me, 3 significant digits, not 3 decimal places, 3 total significant digits. You're going to round it to the 596. This is greater than 5, so you round it up and you put 597. Okay, never again will you need to ask me how many decimal places, because if you come up and you ask me, I'll like, look at how many significant figures you have, right? Because that's how you determine how many decimal places you're going to have. All right, so a couple of problems here, all right? What we're going to do is we're going to figure out how many significant digits we should have in our answer, okay? So this one, we're multiplying, so we're going to use our multiplication rule, okay? And you're multiplying 1, 2, 3, 4, 5 significant digits by 2 significant digits. So your answer should have 2 significant digits in it, and only 2. Okay? And so, when you work that out, you get 5.4 times 10 to the 7th if you're putting your answer into scientific notation. All right? Next one. 5,678.44 plus 2.2. All right? You're adding. So you need to use your addition rule. Your addition rule says that you're going to keep the least number of decimal places, or the place of the last significant digit. Okay? So you're going to answer this to the 10th place, because that's tenths, and this one has hundredths, right? You're going to answer this to the 10th place. So you're going to get 5.6806 times 10 to the 3rd. But wait a minute, that's not the 10th place. Ah, but it is. okay, because this number, if it's written out, looks like that, and it is the 10th place, okay? So if you're putting it in scientific notation, write it out first, then convert it into scientific notation, okay? It might look like you have more decimals than you're supposed to, but you don't because it's in scientific notation, okay? Now, if the numbers are already in scientific notation, here's a nice thing about scientific notation. If the number is in the base of scientific notation, it is significant, period, the end. You don't have to think about the rules, okay? Because 2.300 times 10 to the second, well, these are trailing zeros and there's a decimal, okay? If it's in scientific notation, every number in the base is significant, okay? So this one has 3 and 3, you're multiplying, so you're going to keep 3 significant digits and get 3.05 times 10 to the minus 6. Okay? Let's do some practice with that. All right? This is a really, really important concept that is going to go all year. Okay? All year. And then in classes that you take after chemistry, you're going to need to do this again and again and again. All right? You have to get this, guys, or you will lose lots and lots of points just because you don't feel like doing significant digits. Sorry, it's mean. I know, I'm mean. But I gotta do it. All right, there's a couple special instances where you're gonna have to pay pretty close attention to the significant figures and such like that. The first is when you're adding or subtracting using scientific notation. Now remember, when you're multiplying or dividing, you just look at the least number of significant digits and that's what you do, all right? But when you're adding or subtracting, it's a little different because you're looking at the number of decimal places. Well, you moved that decimal around to put it in scientific notation, right? So you got to pay attention to that, okay? So when you're adding or subtracting numbers in scientific notation, what you have to do, you have to make sure that the two numbers have the same exponent. Okay, for instance, you got 1.34 times 10 to the second minus 2.1 times 10 to the third. Okay, well, in this case, you got 1 times 10 to the second and 1 times 10 to the third. All right, but in order to really add them and pay attention to significant figures, what you've got to do is you've got to change either one or the other exponent so that they are the same. Okay, so what we're going to do to change this 10 to the second to 10 to the third is you're going to move the decimal to the left one more place. So it's going to be 0.134 times 10 to the third minus 2.1 times 10 to the third. Okay, and then when you do the calculations, you can use that significant digit rule, where the least number of decimal places is how many decimal places you're going to keep. Okay, and the exponent is going to remain the same. So 0.134 times 10 to the third minus 2.1 times 10 to the third is negative 2.0 times 10 to the third, keeping one decimal place. Okay, so that's one place you got to be careful. Now, usually when you're multiplying a bunch of numbers or dividing or whatever, you're just going to look at all the numbers at the same time, take whichever one has the least number of significant digits and round your answer to that. You don't have to round in the middle. Same thing if you're adding or subtracting. If you're adding a whole bunch of numbers or subtracting a whole bunch of numbers, just look at the whole thing, round to that number of decimal places, okay? The only time you have to round in the middle of the question is when you switch rules, okay? So when you're adding numbers and then you multiply, or when you're dividing numbers and then you subtract, whatever, you've got to round when you switch the rules and then finish the problem and round again, okay? This is the only time you will round in the middle of a problem. All right, let me give you an example of that. So 2.3 times 5.33 times plus blah 132.9. Okay, so we're going to do order of operations, do parentheses first. Okay, 2.3 times 5.33. Okay, now notice after that you're going to add. So because you're switching rules, you're going to round after you multiply those. Okay, so 2.3 times 5.33 gives you 12.249. 2 significant digits, rounded to 12. Then you've got 12 plus 132.9. Add those up. Take the least number of decimal places, which is none, right? The last known number there is the ones place, so you're going to round it to the ones place. Okay? So that gives you 144.9, but you round that to 145 with no decimal places. That's the only time you're going to round in the middle. And it doesn't come up that often, okay? But you just need to be familiar with that.